Again, welcome to ITCO341. And this is again IT course. And today we're going to study about quartiles, interquartile, and z-score. So this is our Unit 3, Part 5 lectures. So our main objective, again, the measure of position. Normally, the measure of position is normally the quartiles. For example, we can know the 25 percentile, which is the quarter one. We can know the 50th percentile, which is the median. Then 75 percentile is the Q3. So we can know the Q1, Q2, and Q3. And we're also going to discuss about the interquartile. Interquartile normally is the difference between the Q3 and Q1. And also how to find a z-score. And we shall also explain what is a z-score. So we're going to determine the quartiles of a data set. Also determine the interquartile range of a data set, how to create a Box-and-Whisker plot, and also to interpret other percentiles. And also we're going to determine, interpret the z-score or the standard score. So fractals are numbers that partition, which means dividing an other data set into equal parts. So for example, quartiles means 4. So we are going to divide the data set into 5 different parts. That's why we say quartiles give us the positions of a data set or data entry. So fractals are numbers that partition or divide an other data set into equal. For example, we can have the quarter 4 parts, and this set which will be 10 parts, etc. So quarters, again, divided into 4 equal parts. The first quarter, which is the Q1, we say about 1/4 of the data fall on or below the Q1, which is the 25%. Then second quarter, which is the Q2, is about 1/2 of the data fall on or below the Q2, the median also. The reason why we say the median is that anytime we are looking for quarter, we have to put the data in ascending order. We have to sort it or put it in order, increasing order. Then the middle value will always give us the median. So the same thing as the Q2 also. Then the third quarter will be the above 3/4, which is 75% fall or below Q3. So let's see one example here. Finding the quartiles. We have a data set. This data set is it's about 15 employees that enroll in a CPR training course. And this is their test course, 15. So in order to find the quarters, first we have to put this data in an increasing order. So we can see the lowest value is 5, the highest value is 37. Then we divide the data into 2 equal parts. So we can see that since we have 15, this will give us only one middle value, which is the 8th position. So at the moment we have 15 will give us Q2. We go to the left side, the middle of the rest will give us the Q1, the 25%. Then we go to the right side, the upper half, the middle there will give us the Q3. So first we look for the Q2 is given. Now if, let's say the data set is 14, here is 15. That's why we got one middle value. If it's 14, then we are going to get 2 middle values so we can find the average of the 2. So now we know the Q1. Now when we go to the left side, we have luckily 7 data sets. So if it's 7, then the middle will be the 4th position, which will be Q1. So Q1 will be 10. Then when we go to the right side, we also have 7 data sets. So the middle is only one value, 18, Q3. So this is how we find the Q1, Q2, Q3. So here we can say about 1/4 of the employees score 10 or less. because that is the 25% at Q1, is 10 or less, so 1/4. Then we can say about half is 15 or less. And we can say that 3/4 or 75% scores 18 or less. Or we can say that 25% are 18 or greater than 18. So I'm going to my right, greater. So this is how we find again the quarter. We have a data set, put the data set in order, look for the middle value, you get Q2. Go to the lower half, look for the middle value of those data sets, you get Q1. Go to the right upper half, look for the middle value, that will give you Q3. That's why we say the quarters will give you the position of the data. Now, when we are looking for the mean, median, mode, that gives us the central tendency of the data set, the center. And then when we're looking for the variance, standard deviation, and deviation, that will give us the concept of how the data varies. So if the standard deviation value is 0, it means all the data are the same. If it's lesser, that means the data are very close. If the standard deviation is greater, that means the variation of the data is very large. So next we go to the interquartile. Interquartile range normally is the difference between the third and the first quarters. So it will be Q3 minus Q1. Also, the interquartile will help us to find what we call the outline data. If the data is too small or too large. So the data set that was given us previously, we were able to find the Q1 to be 10, Q2 is 15, Q3 is 18. Now, if I want to find the interquartile, that would be Q3 minus Q1, which will give me 18 minus 10, and that will give us 8. So interquartile again is 8, the difference between Q3 and Q1. Now, next, there's a special plot, or I'll say a graph, called the Box-and-Whisker plot. We can use the Box-and-Whisker plot also to tell us the positions of the data set. In the Box-and-Whisker plot, we can see the minimum value, we can see the maximum value, we can see the Q1, Q2, and Q3. And normally we use it to know the position of the data set also. Maybe we can say that, okay, 50% of the score are greater than 50 or less than 50, 60, etc. This will highlight the important features of the data set. So the Box-and-Whisker plot also is a very important exploratory data analysis tool. So we need at least 5 numbers. As we said earlier, the minimum value, Q1, Q2, Q3, and the maximum value. And this is how so the steps is that first we have to find the 5 summary of the data set, which is the minimum, maximum, Q1, Q2, and Q3. Then we draw horizontal scale. So that's a good example. We draw the horizontal scale here, so we can see the graph. The minimum entry, again, hopefully everybody can see the cursor. Please follow the cursor. So the minimum entry, the maximum entry, Q1, Q2, and Q3. So we'll see an example right now. So we are using the same data set in the first example. We quite remember when we look at the data set, the minimum value was 5. The maximum value was 37. We find the Q1 to be 10, Q2 to be 15, Q3 to be 18. So with these 5 data sets, we can come up with our plot. So we have our horizontal line, we have our 5, our 37, then Q1, Q2, and Q3. Now, any data that is greater than 37, we can say is outline, or any data that is data entry that is less than 5, we can also say is outline, minimum. So percentiles and other fractals, as we said earlier, deciles means divided into 10 equal parts. Quartiles means divided into 4 equal parts. And percentile, of course, is 100, percentage, 100 equal parts. So we can get P1 to P99, D1 to D9, which is deciles, then quartiles. So interpreting the percentiles, here we said we have a data set representing the cumulative frequency distribution for SAT test score of a college-bound students in recent year. Now, what test score represents the 72nd percentile, and how should you interpret this? So represent again 72nd percentile. So here we can say that this is our data set. Based on the data set, this is a graph we get. So 72 percentile means we have a score. The score will be 1,000, almost 1,700. So we can say the 72 percentile corresponds to a test score of 1,700. This means that, again, 72% of the students had a SAT score of 1,700 or what, less. You can see the arrow start the line, so less. Now, based on this, we can say the remaining 72, we have 28%. We can say that the 28% of the students score above 1,700 or more SAT score. So quartiles or percentiles are normally used to find the positions of the values. And this is a very good example. We have a test score given, and also percent of students who pass it, they get a score. So 72% tells me 1,700. So 72% of all the students get a score of 7,200 or less. Standard score, normally we use the term z-score. Now, it represents the number of standard deviation a given value S fall from the mean. By looking at the definition, which means if I'm looking for the z-score, I'm going to subtract a value, each value from the mean, and divide by the standard deviation. Because the z-score or the standard score normally represent the number of standard deviations that we have. So we divide by the number, the standard deviation value. A given value X, that's one data entry from all the data set, fall from the mean. So Z value will give me the value that I'm looking for, the z-score, the value of the z-score I'm looking for, minus the mean of the whole data set divided by the standard deviation of the whole data set. So this will give me X minus mu over standard deviation. So this example given to us, they said in 2007, Forrest Whitaker won the Best Actor Oscar at age 45 for his role in the movie The Last King of Scotland. Helen Mirren won the Best Actress Oscar at age 61 for her role in The Queen. The mean age of all the Best Actors winners is 43.7, with a standard deviation of 8.1. So the mean age of all the Best Actress also is 36, with a standard deviation of 11.7. Now they say we should find a z-score that corresponds to the age for each actor or actress. So here we can see one thing is that always when the mean is greater than the value, we are going to get a negative z-score value. But here we get positive because Forrest Whitaker age is 47. The average age for all the actors is 43.7. So we get 0.15 standard deviation above the mean. And Helen Mirren also is 61 years. The average is 36. So we can see that the z-score went up because the difference of the age is very high compared to the average. Also, comparing z-score from different data sets, we always say that the z-score corresponding to the age of Helen Mirren is more than 2 standard deviation from the mean. So this will be considered unusual compared to other best actress winners. As I said earlier, 63, the age is high, so she's relatively older, whereas age of Florence Whitaker is only slightly higher than the average age of other best actors winners. And based on this, we can see the Z 0.15 for Forrest Whitaker, and Ellen is 2.17. So relatively comparing the age, Ellen is older, way older, compared to average of the other actresses. Whereas Forrest Whitaker is closely, age is close to the average mean of the actors. So in summary, we went through what is a quartiles of a data set, what is interquartile range of a data set, how to create a Box-and-Whisker plot, also interpreted other fractals such as percentiles, and also determine and interpret the standard score, Z-score. Hopefully this lecture will help us to solve around 2 of the questions, I'm sure question 5 and 6 or so of our Unit 3 IP assignment, which is related to finding the quartiles. Again, if you have any question, feel free to contact me. Thank you. Bye.